Okay, I'm going to go over 19, and I want you to correct me if I'm wrong, because as you well know by now, that's very possible, if not likely. So what happens is f of x is going to be equal to the integral of f prime of x dx, right? And then to do that, in this case, we're going to have f of x is equal to the integral of x squared minus 2x plus 2 dx. Are we okay to that point?
Yes.
Okay, so now to f of x is going to be equal to, I get x cubed over 3, does that look right? Minus 2x squared over 2 plus 2x plus c. So those will cancel out, so we get 1/3 x cubed minus x squared plus 2x plus c. Does that look right? Okay. Does that look right, Carson? All right, what goes on next here? Yeah, so Hannah's right about that. And what do we call this thing right here that we did? Called a general solution. And as Hannah rightly says, if we plug in, so f of 3 is -1, so -1 is going to be equal to 3 cubed over 3 minus 3 squared plus 2 times 3 plus c. And what is this going to be? It's going to be, that's going to be 27, that's going to divide by 3, that's going to be 9 minus 9 plus 6 plus c. So those will cancel. So I'm getting c is equal to -7. Does that look right? Is that right?
Yes.
C is -7. And now we can write what we call our, what do we call our solution here? Particular solution. Our particular solution is going to be this thing here, f of x is equal to x cubed over 3 minus x squared plus 2x minus 7. So that'll be our particular solution. All right. What I want you to do is go to the next problem, which is, I think it's 20, and do that one. I think that's one where we're given f. Is that when we're given f double prime of x? Yeah, so go to number 20 and do that one, and we will review that in a few minutes, okay? So here we're given an f double prime, and what we're trying to do is we're trying to find the equation for f of x, the particular solution for f of x from this. How are the right hands doing working on this right now?
Not very good.
Kind of lost.
Can you do 20 and then we do 21 on the road? Because I don't understand what you're doing.
No, that's okay. I want you to try it. I'll give you a hint on, I want you to actually do something on 21st. I'll give you a small hint. How's that? What is, I will tell you, I'll give you like a starting hint on 20. How's that? Okay, F prime, I'm going to make a skinnier pen here, give myself more room. Okay, we're given this, our initial function we're given is f double prime of x. That's what we're given. So f prime of x is where we're trying to go next, is equal to the integral of f double prime of x dx. And so therefore f prime of x is equal to the integral of 2 dx. And then once you find this, the f prime of x function, you'll be able to plug in and get the particular solution, and then use that particular solution here to advance to the f level. Does that make sense? No, Gavin's going. Yeah. And so you're going to be finding a particular solution in this instance twice to get to a final answer.
I know you did the deal breaker when this man. You're walking. I heard you talking about the game. No, I said it, and then I gave it all to him. Are you talking about running that way?
All right, Gavin. How are you doing on this, Hannah?
I could lie to you.
But you're going to be on. So you're not doing very much on this right now, what you're saying?
I just,
See, what I'm angling for is when you have your final next week, and I see the problem that this one is emulating, then I'm going to see, wow, look at that, everybody got this one right. That's what my dream is for the work we're doing right now.
I'm sorry, I wrote in dream, Mr. Chief.
But the thing about it is, you can't. I don't want you to give up, because that's like a defeatist thing. I don't want to hear the attitude of defeatism. I don't think that's helpful.
It's not defeat, it's acceptance, Mr. Chief.
It's acceptance?
Acceptance.
All right, look, when you did problem 18 and 19, what was hard about those problems?
I'm sorry?
The doubt.
Okay, so let me go ahead. I'm gonna finish working out 20. See, I started it. And so this one right here, our answer for this is going to be 2x plus c, right?
Yes.
Okay, and now what are we going to do? We have this. So I know f prime is equal to 1. So 1 is equal to 2 times 4 plus c. And so solving for c is going to be equal to -7. Does that look right? Now, then we know now as a particular solution f prime of x is equal to 2x minus 7. Okay, what do we do with this 2x minus 7 now? Yeah, but, okay, so Hannah's telling me, Hannah is telling me the mechanics of it, so that's good. But before I do the mechanics, I want to set up what that actually represents. f of x is equal to the integral of this thing right here, isn't it? Dx. And what is that going to be equal to now, Hannah? You can do your work. It's going to be 2x squared divided by 2 minus 7x plus c. And so now we have our general solution. And what's the last step here? 2 is equal to, okay, we have x squared, so it's going to be negative 1 squared minus 7 times negative 1 plus c. So 2 is equal to 1 plus 7 plus c. So that's 8, subtract 8, so c is equal to negative 6. Does that look right? So now we know that f of x is equal to this general solution here, x squared minus 7x minus 6. Okay, is that very hard? That's not hard, is it? Do music. Okay, what I want you to do now is, I think Hannah did have a good suggestion, that I work out number 20 first. Now you can do 21. Yeah, we'll see how it goes. And we can have more, because these are just like mechanics, and we could do more of these too between now and your final as well. And I like this as kind of a good problem, because to me, if you do this, it sort of compiles, doesn't it, some of the different things we've been doing.
And then the opposite.
Okay, for f prime of x, I end up getting x squared plus 5. Does that look right? Yes, no, maybe?
I wasn't there. I was scared I got there, but I didn't.
You didn't? Okay, good. Does that look good?
Yeah.
Aaron, does that look right? Okay. All right, and now, how do we find f of x? We take the integral of f prime of x, right? And I'm gonna get room. I'm gonna bring this up here. So I'm gonna get f of x. I'm getting x cubed over 3 plus 5x plus c. Is that right? And what's the next step we do? So -1, and we plug in 2 here, so we have 2 cubed over 3 plus 5 times 3 times 2, excuse me, 5 times 2. Is that 5 times 2? Yeah, it's 5 times 2, isn't it?
Yes.
5 times 2 plus c. So here, this is like -1 equals 8/3. And this is 10, isn't it?
Yes.
So that's going to be like 30/3, right? So we have, so we have -3/3 equals 38/3 plus c, and now we subtract, and I'm thinking c is equal to, is that -41/3? So here we got into a little bit of fraction messiness, but now we have our answer, don't we? We have f of x is equal to x cubed over 3 plus 5x minus 41/3. So yeah, a little fractional messiness, but that isn't so bad, is it? It shouldn't be that bad. Okay? All right. I think with that, we're going to try to go to the next note card, which is actually 39 is the next note card, which is sigma notation. And we're going to kind of skip over 39 and go to 40. And okay, so here we are at note card 40. And what? Okay, what 40 is, you remember the exercise we did at the very beginning of the school year where I introduced the integral symbols, and I had you calculate, it's like fundamental theorem of calculus, and you did that, and I got you introduced to the integral symbol, and also a little bit using the calculator. What they are. What this is, I remembered bring my shirt. And so this is the other shirt that I had, but the one that, okay, and the one that you had as your class shirt was, if I remember, I don't have that shirt with me, but it was something like that. What is, or how many, like there are so many times people in the world. So I think it's 0 to 1, and it's something like x to the 4th dx, or something like that, or x to the 3rd dx. I forget exactly what it was. You remember what your shirt says?
I think it's like,
or is it
1 to 2?
From 1 to 2? Well, it's not going to be 2 because the answer is 2. I didn't want to have that same number in there.
Maybe it's 2.
Yeah, maybe 0 to 1. So what this is going to be, this is going to be, the answer is going to be x to the 4th divided by 4, and we're going from 0 to 1, so we get 1/4. So it's probably 4. Let's see, because that's 1/4. No, it's 8. That's right.
Yeah, it's definitely 8.
It's 8x cubed. So work backwards and see what's on that shirt. So we have 8x cubed. So this is your answer. This is what it is. So that's the one that's on your shirt, and you work that here, and you plug in 1. You get 8/4, which equals 2. So that's what's on your shirt. But graphically, what that is, that's this function right here. You got this 8x cubed that looks like this, and you're looking for the area under the curve between 0 and 1. So the answer to the question is this. The answer to the question is this area underneath that curve. And I bring that up at this time because that's exactly what we're talking about. We're talking about the area. It says from A to B, and I have written down here from 0 to 1, and f of x is 8x cubed. And so the region bounded by the x-axis and the vertical lines, x equals a, so we have a vertical line at x equals a, we have a vertical line at x equals b, and that is always positive above the line. But the definite integral of an integral f of x can represent other fields: profit loss, water consumption, entrance, exit into a store, and can be positive or negative. And the negative, if we have that area where? Where do we have negative? If area is below the x-axis. So what we're looking at in this section is graphically determining what this is, just like the exercise we did at the beginning of the school year. And so here we are now. Here we have set up a definite integral that yields the area of the region denoted by f of x equals 9 square root of 9 minus x squared. What is that the graph of? What is the graph of that thing?
That'd be a semicircle?
Yeah, it is a semicircle with radius
3.
with radius 3. So did you remember us talking about that earlier this year? Is that what you did, or?
I remember talking about it.
Remember talking about it?
Not knowing what you were talking about.
Yeah, okay. Well, that's good. And this is one of the things that's actually hard to do, but if you just recognize what it is, and let me show you, I'm going to recreate how we got here. If we have x squared plus y squared equal to 9, okay, because the circle is x squared plus y squared equals r squared, and we solve for x, so we get y squared is equal to 9 minus x squared, and so what is y equal to?
The square root.
Y is equal to plus or minus 9 minus x squared. And so that's where we have we know we have a circle with a radius of 3. Okay, so let's go and work this out. So what we have is here's our semicircle with a radius of 3. And so what are the limits or boundaries of integration? -3 to 3. And so what is this area going to be here?
Well, you have to enter.
Okay, area,
Oh.
area is going to be the integral of 9 minus x squared dx. Okay, and what is that? And we're going from actually -3 to 3. So what is that area going to be? pi times 3 squared over 2. So equals to 9/2 pi. So that's going to be our area of that. So that's the integral of that. So you're really talking about areas below, above and below the x-axis. That's really what you're looking at here and analyzing what that is. And again, looking at the beginning of the year where we went through those exercises, that's exactly what we were doing. Okay. So that's the setting up of a definite integral. And what's the distinction between indefinite integrals, which is what we were doing earlier today and before today, compared to the definite integral? What's different about this? Okay, you're finding the area, but the difference about this is you have these guys right here.
What do those mean? Why don't they mean?
Yeah, sometimes they're called the limits of integration or the bounds of integration. So limits are bounds of integration. And and the reason that it's kind of focused in my mind right now is that I had one of my videos, I had a very smart calculus guy question a few things on my video, and one of the things he asked, he says, well, I mentioned the limits, and he says, well, aren't they bounds? Well, when I say limits, I mean limits of integration, because it's not, just to say limits is not right. So it's going to be either limits of integration or bounds of integration. So when I say limits in this case, that's kind of a shorthand abbreviation for limits of integration. So you'll have a lower limit and an upper limit. Those are limits of integration. And he asked me a couple other things. One of those guys. It was one of those comments. The guy made this comment, and that was one of the questions he asked. And he mentioned a couple other things. And I told the guy that a person looking at your comments and questions and reading them could learn a lot about calculus just from that. So the right question can get you a long ways. Okay, ready to go on here? Questions about that? Okay, let's go here and look at this next one. And here we have a linear piecewise function to the right. Has given points and is defined between -2 and 3, and then we're asked the question, what is the value of this integral here? So I want you to define what the value of that integral is. What is going to be the integral here? It's going to be what minus what? Okay, it's going to be this area above the x-axis and what? Minus this area here. So here you have the area of a triangle minus the area of this trapezoid. And you should be able to see graphically to get enough information to figure what it is. And it's really sort of it's really a simple area problem at this point. So we have 1/2 base, and my base I'm getting 1, 2, 3 1/2. I'll call it 3.5. Base times height. 1/2 base times height minus this area here, which remember the area of a trapezoid? It's 1/2 of base 1, It looks like 1 and base 2, which is 1.5. And so that's going to be it. So you're really talking about like 1/2 of 3 point, let's see, 1/2 of 3.5, that's going to be 1.75, I'm working with decimals, times 3, minus 2.5 over 2, so that's going to be 1.25. And I'm trying to think of what it is. That's going to be 1, 2 of those is 3.5. Then let me put this, let me write here 7, it'll be easy like this, 7/4 times 3, that's going to be easier for me, minus 5/4. So 21/4 minus 5/4 is 16/4,
Just 4.
which equals 4. So 4 is going to be our area here for this. So that's really what you have to look at for this. Let me just look at this next one here. So, yeah, so we're going to look at these exercises here starting on Monday. So really that is it.